Hey makers, welcome back to HUB360 Embedded Sphere, your go-to stop for building real-world IoT and embedded systems projects. In today's tutorial, we'll be building a smart digital weighing scale using the HX711 load cell amplifier and a 20x4 I2C LCD. This system reads weight accurately, applies filtering for smooth measurements, and displays the stable reading on an LCD. Components used: we'll be using an Arduino Uno, a load cell weight sensor, a HX711 load cell amplifier, a 20x4 I2C LCD display, jumper wires, mini breadboard. For the connections, first you connect the load cell to the HX711 load cell amplifier. For the connections, first you connect the load cell to the HX711 load cell amplifier. Then we connect the HX711 amplifier to Arduino. Connect the VCC pin of the HX711 amplifier to the 5 volts of the Arduino. Next, we connect the grounds together. Next, we connect the DT pin of the amplifier to the pin 4 of the Arduino. Next, we connect the SCK pin of the amplifier to pin 5 of the Arduino. Now move to the LCD. We'll connect the VCC pin of the LCD to the pin 5 volts of the Arduino. Next, we'll connect the ground of the LCD to the ground of the Arduino. Next, we'll connect the SDA pin to the pin A4 of the Arduino. And finally, we'll connect the pin SCL to the pin A5 of the Arduino. Note, on Arduino Uno, I2C pins are A4 and A5. On Mega, they are 20 and 21 for the SDA and SCL pins respectively. Note, on Arduino Uno, I2C pins are A4 for SDA and A5 for SCL. On Mega, they are pins 20 and 21. Let's break down the code step by step. Libraries used: we use the HX711 ADC. This handles the load cell amplifier. The liquid crystal I2C library. This drives the I2C LCD. The wire.h enables I2C communications. Here we define the pins. HX711 is connected to pins 4 and 5. LCD address is 0x27 with 20 columns and 4 rows. This is for the calibration. This value is unique to your load cell. You will determine it during calibrations by comparing known weights. This is used for filtering and stability. Filter strength. This smoothing noisy weight readings using exponential moving average (EMA). Stability threshold. This detects when the reading stops fluctuating. Now for the setup function. This starts serial communication for debugging. This initializes the LCD with a welcome message. This initializes HX711 with stir that sets the zero weight. This displays weight scale ready. If wiring is wrong, it prints HX711 error on LCD. For the main loop, this runs continuously. This reads the weight from HX711 and apply filter. It also checks stability. If the difference between the current and previous weight is less than 0.5 gram, it's considered stable. After 1 second of stability, reading is logged as stable weight. This is now updated to the LCD and serial monitor. It shows lightweight or stable weight with a star indicator on the LCD. This display function shows live reading, that's the fluctuating reading, and also shows the final locked reading and marks it with asterisks on LCD. The tire function, this is actually optional. It helps to reset the scale to zero weight. It's useful when using different containers. Upload a code to Arduino. Open the serial monitor. You will see both raw and filtered weight values. Place a known weight. Wait for stable lock. LCD shows the weight in grams with smooth and accurate display. In this project, we successfully built a smart digital weighing scale with load cell plus HX711 for accurate readings, LCD display for real-time monitoring, filtering for smooth values, stability detection for reliable measurements, and optional tire functionality. This can be extended into kitchen scales, luggage checkers, or even smart IoT-based weighing systems. All the components used in this tutorial are available at HUB360.com.ng, Nigeria's trusted embedded systems store. Like this video if it helped, subscribe so you don't miss future tutorials. Until next time, keep building, keep innovating. This is HUB360 Embedded Sphere, helping you bring your ideas to life.